Hello, physicists. Today, I'm going to be giving you a lesson on mathematical modeling. It is I, Miss Wolf. I can't talk like that anymore. It's too hard on my voice. All right, welcome to a riveting lecture on mathematical modeling. Yay, just hands. Okay. So mathematical modeling is when you make an equation into like a general equation you can use for any situation that applies to this particular equation. I'll get more into that in a second. Anyway, so this is an experiment that we do in general physics, but not in AP physics. We start with a rope that is a meter long, and we tie knots in it, and then we measure the length of the rope after every time we tie a knot. So after you tie one knot in the rope, it goes down to 0.8 meters, and we tie another knot in the rope, and it goes down to 0.6 meters, 0.4 meters, 0.2 meters, and then after that, you can't really tie any more knots in the rope. It would never actually go down to 0, right? Because you still have physical rope there. You're just making it shorter and shorter and shorter. Good. Okay, so we make this graph, and we can make an equation line from that. We've got a slope of, well, every time we tied a knot, it went down by 0.2 meters. So negative 0.2 meters per knot times x plus 1 meter, because 1 meter was our y-intercept. Cool. So the only problem is this equation only holds true for this particular rope. And we actually graph another rope that has a smaller diameter, and it actually comes out to have less of a slope. So a smaller diameter rope kind of looks like this. And so what we see is that it doesn't actually, this equation doesn't hold true for every single rope. But we could turn it into an equation that always holds true for every single rope. So what we do is we start with y equals mx plus b, and we're going to try to find the meaning of each of these variables. What does y mean? What does x mean? So y and x are actually pretty easy. Y turns into, well, what is it that's graphed on the y-axis? It's the length. So y just means the length of the rope. So y can turn into L, and then we want to just be careful that we also define the variable that we're using. So L stands for length of rope. Whoops, I just wrote our dean's name instead of rope. I wrote Rhodey. Length of rope after each knot, right? Okay, and then x is similar to, well, what did we graph on the x-axis? It's just the number of knots. So x, I'm going to put a k for number of knots. Okay. And that's just because that's what we graphed. We were looking for a relationship between the number of knots and the length. So our y equals mx plus b model is a relationship between, guess what? The number of knots and the length. Okay, so now slope gets a little harder, but I always make you do 2 experiments, and that's so that you can kind of see what things affect the slope. And it turns out the diameter of the rope affects the slope, but not in like a perfectly measurable way. But every knot makes the length of the rope go down by the same amount. And so if you have a smaller diameter rope, it makes it go down by the same amount but less. Bigger diameter rope, it makes it go down by more. So we could call that the rate of decrease of the rope per knot. So I'm going to call it RD. I'm going to come down here where I have more room. and that stands for the rate of decrease per knot. So the rate of decrease per knot. All right, so now the B, what does that mean? Well, that's our y-intercept. So we come here. So what does our y-intercept mean? Well, we had a 1 meter knot, just 1 meter rope to start with. And if we look at our y-intercept, let's see, it's on the y-axis, so that means 0 knots. So at 0 knots, we have 1 meter of rope. So what does this y-intercept tell us? It tells us the initial length. And I'm going to do a Li. In physics, often we do a little I to say initial. And you could actually do a little F here to say final. L final and L initial. All right. So I'm going to define this variable. This is the initial length of the rope. Cool, cool, cool. So this is what mathematical modeling means. Now, if you hand me any rope at all, I could tie 1 knot and measure the rate of decrease, and I could measure the initial length of the rope. And now I have an equation that I could use for that rope. So mathematical modeling is all about generalizing an equation to make it something that you can use in any case. So for your lab, I want to show you, you're going to go to your lab analysis page. Looks something like this. And on your lab analysis page, you should see where it says tape your foldable in here. You're going to go to the back of your notebook. And there's a place where you have extra graph paper, and I have these foldables. You're going to cut one out. Be careful if you're reaching your end of your foldables, be careful not to cut, like leave a little room in the back, because if you cut this page all the way, it will break and then your notebook will start to fall apart. So cut out your foldable and then tape it where it says tape foldable here, like this, so it flips up, that. Okay, and so what you're gonna do is under the Y, on the page, you're gonna put the variable that Y turned into, so I put an L, and then on the underside of your flap, you're gonna define that variable. So I wrote length after each knot. So put the variable, say what the variable means. So M turned into R little d, and that stands for rate of rope decrease per knot. X stands for, turns into a K, and that stands for number of knots. And then B turned into L sub little I, and for initial length of the knot. So that's what you're gonna do on your notebook. Now, if you are in general physics and you are watching this for the very first time, that means you just did this lab. And this is just an example lab, so you get to literally copy what I just did. If this is not the Not Fun lab, then you have to use this as an example to try to come up with your own equation. So if you're doing Drive Me Crazy lab, which you will do next, or if you're in AP, your first lab is Drive Me Crazy lab, you should not be writing the length of rope for Drive Me Crazy lab. That doesn't make any sense. So do not just copy this equation down on your page if you're working on Drive Me Crazy lab. This is just an example. Now the next thing that you're going to do is you're going to record a Flipgrid. Not for Not Fun lab, but for Drive Me Crazy lab. If you are doing Drive Me Crazy lab or any other labs, you're going to record a Flipgrid as your lab report. So instead of writing up a multi-page lab report, you're just going to record yourself. You're going to just record yourself showing me your equation in your notebook. You can choose to show your face or you could choose not to show your face. So you're just gonna show yourself showing me your equation in your lab notebook, explaining what each of the variable means, and then explaining your reasoning for why each of the variables turned into what they did. And so I just gave you an example of explaining the reasoning. And by the way, the reasoning for y and x, that's always going to be the same. It's always going to be the same because that's what's graphed on the y-axis, because that's what's graphed on the x-axis. Your reasoning for your slope, well, you're going to have to figure out what the evidence is, like why you think that. And you might want to use, oh, hey, some of these sentence frames that I gave you already. Like that's why this is on the same page. So I gave you this to think about, to use to figure out what the meaning of your slope is, right? So tell me what your evidence is for what you came up with the meaning of your slope. Same thing for the y-intercept. Now, there's a couple of different cases with the y-intercept. Your y-intercept could always be 0. So if you get a 0 y-intercept, you want to look at your lab and be like, is there a reason why every time I repeat this experiment, it's always going to be 0? That would not be the case for this not fun lab, right? But there are some labs where it is the case. So you'd want to state a reasoning, like why would it always be 0? Or it might represent something, like in this case, it represented the initial length of the rope. And so you're going to want to reason through, just like what I did here, why you chose what you did instead of B. All right? Good luck, physicists. I know that you can do it. Use the force.